Hi dear students, in this video we are going to explain the sample space diagrams. This is the second video about the probability. When you have experiment in probability, of course sometimes you may have many results, and it's always better to show them by using the table. So we are going to use table, and these tables are called sample space diagram. And here, when we toss the coin, if you remember, it should have head or tail. H represent head and tail represent T. Actually, T represent tail. It's going to be. Here I'm going to make the diagram for that one. Firstly, this is the first coin, and this is the second coin. It's going to be, and when you toss two coin, what is the tossing two coins? So for the first coin there are head and tail possible cases. For the second coin, again the same head and tail, possible cases. So here, as you see in the diagram, when you draw like this, it is easy to match, because two of them head it will be, so head and head it will be, or one of them head, the other one tail it will be, head and tail it will be, or the tail and head it will be, one of them tail, the other one head, and the last one it's going to be tail and tail together, both of them tail and tail it will be. This is the tossing two coin experiment. Also, if we toss two coins, tossing three coins, for this one, this is the first coin, and here the table of two coins I'm talking about. So from the table of two coins, it will be head and head, it will be head and tail, it will be tail and head, and it will be tail and tail. From this table, you know. Now I'm going to add three to this one. So when you toss three coin, it's going to be head and tail, tail. So the first coin will be head, second coin will be head, third coin will be head. So the results head and head it will be. So head tail it will be, head tail head it will be, head tail and tail it will be. The second version of this one, tail head it will be, tail head tail it will be, tail head it will be, and the last one tail it will be. So when you toss the two coins, there are four possible outcomes. When you have three coins, 8 possible outcomes it's going to be. Okay, we can continue the exercise with rolling the dice. So here in this exercise, when you roll the dice, how many possible cases we will have? When you roll two dice, for each 6 possible case we have, so we are going to 6 case by the 6 other case. I mean, we are rolling red dice and white dice here. So when you roll red dice, you have 6 possible cases. When you roll white dice, 6 possible cases. When we match these 6 possible cases, 6 times 6, 36 totally possible cases it's going to be, and I'm going to show this one on the table. Here, as you see, the first one it will be 1, second one it will be 1, and the first one it will be 1, and the second one will be 2, first one will be 1, 3, 1, 4, 1, 5, 16. Okay, these are all possible cases. So when you roll two die or two dice, you have 36 possible outcomes. Okay, let's continue with different type of this rolling dice experiment. Here, when we roll two dice, one of them red and blue dice, and we are going to add the sums because the number it's written here, the numbers showing are added. Here, a fair right dice, it says, and there is an explanation here. Fair means the number on each face equally likely, which means all the sides they are equal length, and like cube it is the figure. So the sum of 1 and 1, it's going to be 2, 3, 4, 5, 6, 7. Okay, these are all possible sum when you roll two die. And here, let's see what is the here again. There are 36 possible. There are 36 possible outcomes. So when we divide, we are going to divide by 36. Okay, by using this table, we are going to show all possible outcomes. This is the case A, it was. And use your table to find the probability of getting total 3. To probability of getting 3, I'm going to solve the B here. BI. And total 3 here, as you see in the table, the sum is 3. There are two possible cases. So probability of total 3, I'm going to abbreviate this one. It's going to be equal to 2 divided by 36, which is equal to 1 over 18. It's going to be total 12. Total 12 is only this case here, and it's going to be only this case, as you see here. So probability of this event is, probability of total 12 is 1 over 36, which is going to be, and that's all. Here, total is greater than 6. Total is greater than 6 means here 7, 8, 9, and it's going to be this side. So here for this one, I'm going to do like this. Let's say here, I'm going to check this part here greater than here. This part, all this part I'm going to count, so it's going to be 3i, and probability of greater than 6 is probability of greater than 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Is going to be 21 divided by 36. This is the last one. Now we are going to solve the C1 here. I mean, which total score is most likely here. As you see in the table, the most common sum is 7, and probability of 7, it is equal to 6 over 36. So this is the most common, most likely, we can say here, probability of 7. Actually, you will hear the word lucky 7, and that's the reason also.